Now, I don't have I hats and J hats in there, but that's okay.
My brain immediately thought from like perfect squares.
And that's what we're dealing with here. I can write it out the long way, and we'll ultimately end up with the difference of perfect squares. So let's do it the slightly longer way. So I got VF dot VF outer plus VF dot VI minus VI dot VF plus minus VI dot VI. So just doing FOIL. Well, VF dot VF, I've got a subvector doing a dot product with itself. It's just the magnitude squared. I have VF dot VI and VI dot VF. Well, commutative property holds. It doesn't matter the order in which I multiply. I'm subtracting. Those cancel each other out. Minus VI squared. And that's equal to A dot delta X. Doing some slight rearranging of it, I'm going to bring VI over to the left-hand side, and then I'm going to flip the directions. And so what we end up with here is VF squared equals VI squared plus 2A dot delta X.
Wow.
And we have our third formula.
That's the formula.
And actually, okay, this is the third one I'm writing down formally. There is one that we've already done that I skipped over to actually write it. The idea that displacement is equal to that's the fourth one. So delta X equals VI plus VF. So we've got this one, this one, this one, and this one. Two of them have VF on the left-hand side, one squared though, and two of them have displacement on the left. The left side. There is some textbooks will add a fifth one. There's a video where I think, pretty sure I do the fifth one, but most textbooks don't bother with it. Notice what we have here though. If I know 3 of the 5 quantities, there's displacement, initial velocity, final velocity, acceleration, and time. If I know 3 of them, I can find the other 2 because each of these equations has 4 unknowns. So if I know 3 things, I can have an equation to find the 4th one, and now I have 4 things, I can use whatever equation's left. So let's actually use these. A ball is initially going at positive 40 meters per second. Now the plus sign, I put the plus sign in here just so to indicate that there is a direction. This is a velocity and not just a speed.
That's 40 meters per second.
Yes. It accelerates uniformly along a line at negative 5 meters per second squared. It ends up negative 100 meters from its starting point. is the final velocity. How much time elapsed?
Oh, wow. So many questions.
All right. For chapters 2 and 3, the process is generally the same. When you're dealing with the kinematic problem, we first establish acceleration is uniform, so the Kate formulas work. We've got the Kate formulas to draw on. You then, I would recommend you write down just on the side, the 5 variables. And then figure out what you know. So, what do we know?
Our initial velocity is 40 meters per second.
Wow.
Our acceleration is negative 5 meters per second squared.
We need to know one more thing.
Would that be displacement, negative 100?
Absolutely. I know 3 things. So, coming over here, looking at our equations. So I know VIA, so I know VI, I know A. So this first equation, I don't know final velocity or time. This equation is not going to really help us initially. I know displacement, VI and A. I have only one unknown here. I have VI, A, and displacement. I can find VF. And I know VI and, what did I give over there? I did not give time. Okay.
So
So this equation is not really gonna help us a whole lot. That's not gonna help us a whole lot.
we're gonna use the other 2 to find the 2 questions.
Yeah. So the question is, do recognize this is not finding final velocity. This finds final speed. We have to sort of think through what the sign is gonna be, doing it this way. This way will definitely give us time, then we could plug into this equation and find the actual velocity, or this one, we could find speed, and then think, wait a second, which way is it going? Well, it starts out going to the positive direction, it ends up 100 meters in the other direction. So, at the end, it better be going that way. It has to turn around at some point. Okay. And we'll have a special guest with 5 minutes to go.
Let's get crack down on the problem.
What's that?
So let's crack down on this physics.
All right. Let's nail it so you can go into the weekend thinking, all right, I can predict the future.
Yes.
So which one do you want to find first? It doesn't matter if the order. Oh, on a test, when I might give a problem with 5 different parts to it, the order of the parts is generally the order that when I'm solving it, that's the order I do it in. It doesn't mean you have to. Sometimes it's the way your mind's working at that moment. You skip a step, like you do part B and then you go back to do part A. That's fine. On this one, it really doesn't matter which one we do first. Anyone with an opinion?
Position. Or to find the time.
Find the time. All right, so we'll use the equation down there. So I have negative 100 equals 40t plus 1/2 times 5 times t squared.
Negative 5.
Thank you. So I got the negative 100 is equal to 40t plus 2.5 t squared. And so now I have a quadratic equation. How do you solve it?
Quadratic formula.
So what do you have to do first to use the quadratic formula? Get it set equal to 0. I'm gonna get, so 2.5 t squared plus 40t plus 100 equals 0.
And then we're gonna, x is equal to negative b plus or minus the square root of 4 ac all over 2a. I mean, it's that x 15.
B squared minus 4
Yeah.
times 2.5 times 100 divided by 2 times 2.5. All right, so let's say that, I know it's crazy, some of you don't have the quadratic formula memorized. On quizzes and tests, I put it at the top of the first page. And if you have pop, there's the weasel going through your head right now. I'm really
X is
sorry.
equal to negative b. No.
Quiet, Doug, keep it to yourself. All right, so,
Every day of math class. 15 minutes.
oh. I thought something was off. That's negative.
Oh, yeah.
And you have the negative up front, but and you'll get 2 answers. Only one of which is correct. And the answers are. And if you have a quadratic formula button on your calculator, feel free to use it. So that's 10,000, 2,600, so that's roughly 50.
50.99.
Oh, under here?
Yeah.
Oh, that's the whole thing.
Yeah. So just want to say 51 or go.
Whatever. All right, so that's roughly 10 divided by 5, so it's somewhere around 2 seconds. Oh, wait, negative 2 seconds, or. 90 divided by 5, 18, or somewhere around 18 seconds. What do we get?
Negative 2.19. 18.19.
All right, I got 2 answers here. Which one is correct?
The positive one.
The what?
Positive one, the 18 seconds.
Yeah. It happens in the future. What's happening here mathematically is when you go to solve the quadratic, it thinks you're trying to solve a parabola. That I had a time versus displacement graph. It's looking at that. You start out going in the positive direction, going that the slope there would be 40 meters per second. You turn around, come back, and you end up 100 meters back from where you started. I guess that would be a position time graph. It finds the zeros there. One of them is negative, which takes place because before time begins. The math does not know that it started going 40 meters per second. It does not know that there was nothing before time is equal to 0. And so positive answer is the right one.
They're gonna, he's gonna get to a point where they make what's called a physics calculator. then it applies common day like logic and arithmetics into.
I would almost say that's AI, but AI makes too many mistakes right now.
Yeah.
Oh yeah, by the way, on a master set, if you use AI and you come out with a wrong answer, 'cause I can check AI too. If you come out with the AI wrong answer, yeah, there's absolutely no partial credit on that one. All right, and on that lovely cheerful note, we can do future predictions, and we can also tolerate Mike for a couple minutes
I
here.
remember when the ChatGPT first released to the public, I actually took some of your master set problems to see like if it could do them, and it didn't. I was like, okay, so I've got job security right now. 'Cause it did not.
Some were right, some were wrong from when I went in there, but,
Yeah, but it's so confidently wrong, or at least you trust in it because it's a computer, it has to be smart, right? It's got to where like 70% of people will believe, like an incorrect answer.
you heard about the lawsuit that some legal guy
Oh,
Yeah,
did
tried
a
to-
brief
Yeah.
Chat GPT and it made up some cases.
Yeah, at least it made up citations, right? It didn't just like not cite anything. Yeah.
Potentially worse.
Yeah. Anyways, I'm Mike. I'm a tutor with the Learning Center. So how many of y'all know about the free one-on-one tutoring that we have over there? Okay. Now, how many of y'all know about the free drop-in tutoring at the STEM Lab? Oh, finally, some people actually know about it.
Your
So that's-
reputation procedure.
Yes, so that's where I work. That is where you're gonna get most of your physics help if you need it. Y'all luckily at least have the 16 weeks, so you have a slower pace, so it's a lot more forgiving. We do have a one-on-one tutor that does virtual appointments right now, but, like I said, the bulk of your tutoring, I would definitely come over to the STEM Lab. We're in Strickland. It's on the second floor, room 2343. Right now, the hours are 9 to 4. You got the email that I sent with the hours that you can just.
I saw that you sent the email and
Okay.
I did not open it yet.
It's just got hours, location, and then a navigate PDF to if they want to make one-on-ones. Because you can make appointments for other classes as well. I know you want to spend all your time doing physics, but unfortunately, you might have other classes that you have to spend time on as well. I know.
Hypothetically.
Yeah, so like I said, where I work is entirely drop-in. You just come in, put your student ID number, sit down, and you can hang out there and do physics for hours if you want.
Dream come true.
Yeah, a lot of people, they just kind of make a regular habit, say after class, they come over, start working on the master set, labs, even test corrections if you want to bring those in. I won't tell you how to do it, but I will guide you on, what mistakes you made and how you can fix them. Yeah, I think that's pretty much it.
All
Yeah,
right.
I know Fox Speak, so I can help
Yes.
interpret some of the things that might confuse you. I know, what to expect. And so it goes a lot smoother than if you're trying to tackle this on your own.
And Mike had me for Physics 251, 252 a number of years ago, and he's been tutoring / translating Fox Speak for years now. So, and there's a new person I don't know much about her yet, but I do know he knows. He can interpret what I'm asking, and if he can't, he is not afraid to ask.
Yes. Speaking of, do you use Teams? I meant to ask you yesterday. Do you use it at all? Because I like that more than email personally. And Kelly is so responsive to Teams. And I
She's
can't
just
be like
spoiling
that.
it. Yeah, I think Teams usually is up. Occasionally I just get fed up and I shut it down.
Oh, okay.
But,
This is Microsoft.
Yeah, it's just annoying where, you're working along and all of a sudden, ping.
You can do, I think the focus mode makes it like quiet all the notifications.
Yeah, there's still pop-ups though. Maybe Outlook will still do pop-ups even if you turn off the.
Before y'all leave, any questions about any of that?
Nope. And
Okay.
not many of these left, but
Yeah.
here's some of the same information.
Yeah.
You need to take a picture or, I guess I have 2 left.
Yeah, I took some over to the Success Center on a whim to hey, a lot of students are coming in here, can I just put these on the front desk? And apparently they were very popular, so we ran out, and so they're getting more printed off right now.
All right. There it is.
Yep.
Have a wonderful weekend. You can do some of Master Set 2. Master Set's not due yet, but probably it'll be due a week from Monday. And I think, as always, just when you're doing physics, rejoice, because it is physics. No, it's not plugged in. Let me